same building. Right, so I'm guessing you're here to learn what this iOS thing is, right? Which is a good thing. So before we start, can we do a show of hands? Who's a developer? Who's a designer? Product manager? What are you?
I'll do a database and stuff like that. So.
Oh, database, okay. So developer, right? That sorts, okay. How many of you are using, are actually developing for mobile? Whatever, Android, Windows, okay. iOS? Oh, good, okay. Okay. I was doing a prototype session yesterday, and I didn't realize until about halfway through that most of the people in there didn't know what iOS was. And I was going on about all those different ways of designing prototypes for iOS. But so what my aim is today is to give you an overview. It'll be pretty hard in 90 minutes. I usually teach a 2-day course just for beginners and then another 2 days for advanced. But I've tried to compress those 2 days in just 90 minutes. Also, what I wanted to do is, if something doesn't make sense, or it's a bit weird, or you don't agree with me, I want to raise your hand. I want to do it interactive because this is about you learning, not about me talking. So my assumptions are you're sort of developer, tech, you have no exposure to iOS, tech again, and you want to learn enough to become dangerous. You won't learn a lot today because I'll go through a lot of things quite fast because I don't have time to go in detail. But at least you'll have a sort of understanding what's in there and what to expect when you try and design or build an iOS app. So the plan is to understand why iOS and why you should build for iOS. I'm probably a bit biased because I've been doing this for the last 4 or 5 years. So yeah, I'm biased, but I don't think you should look at the mobile platforms in Android or iOS. You should kind of know everything, at least to a sort of simple level. And then I'll go through the tools that you use, so the Visual Studio equivalent in the iOS world. We go a bit through storyboarding as a way to design things visually. We're going to go through all this really nice Objective-C language, which it's going to look really weird to you because it has all this strange syntax that's quite uncommon. I'm going to talk a bit about design patterns and go a bit about a bit more advanced topics, debugging and testing, and how you distribute apps. So we're going to talk about ad hoc distribution, which is a way to distribute without the App Store, and then how to publish an App Store. Yeah, does this cover kind of what you expect from this? Yeah. So we're going to go through, really, really basic until you actually have an app in the App Store. So why iOS? Well, it started about 7 years ago. Well, before 2007, we had all these different phones, right? They were called dumb phones, and they all had different combinations. If you remember, if you went into a mobile shop in 2007, 2006, it was like a rainbow, literally. All these different colors and different combinations, and you had Nokia having that. I think it's called Engage, was it? The horizontal one with different button on both sides of the screen. But the main thing across all of these is the screen was tiny, and it was black and white, usually, just one color, and you couldn't do much with those phones. And then in 2007, this happened, and kind of overnight, it took about 2 years. You went from what you have on the left to what you have on the right. Right? So you went through all of these different styles and people being creative, to everyone kind of trying to replicate Apple. And apart from that guy in the bottom right corner, which probably can't tell you it's a BlackBerry. If you ask me what BlackBerry is, I think it's a good joke. Which is, they're going to go away probably soon. Still, a lot of people want keyboards. Yeah. So the thing to take away is not necessarily that everyone tries to replicate Apple, but people realize that actually the content is what makes the phone successful. Or trying to get a good experience for the user. The phone goes away the moment you turn it on. So you have that piece of glass that is black, but the moment you turn it on, kind of the phone disappears. It's just about what you give the user. That's the most important thing of all, not the phone. The phone is just a delivery mechanism. And obviously the App Store drove the success of iPhone quite massively. So by having apps and App Store came alive, I think 2008 in March. It's amazing what you have there. But why particularly iOS? Why do I think that you should know iOS? Well, let's look at this. There's different phone markets, right? So, sorry, it's kind of small to see, but the thing to take from here is Nokia is dying, Samsung is winning, and there's some Apple there. So if you look at the kind of the smartphone shipments, Nokia almost, it has some stuff there. Samsung is doing really, really well, right? Has quite a big chunk. So they're the same graph, but this one is 100%, right? So that's 100% of the market. So you see Samsung has quite a big chunk of the market. While Apple has a small bit. But the most interesting thing is if you look in terms of revenue and profit, this is where things are different. Samsung is going more towards the bottom line and trying to they release thousands of devices just to cover the market. But if you look in terms of profit, that's a percentage. You can see that Apple is taking almost 80% of all the profits in the smartphone market. And that's for hardware. So that kind of tells you something. That they make money, they're going to invest in technology, they're going to keep going. Say that again?
That means you're being a bit more.
If you think of that, yeah. How many of you have Android phones? Windows? iPhones? Okay. Android guys, can you raise your hand again? Okay. Who do you think made most money from Android hardware? Well, Android as an operating system, not other services, last year. Microsoft or Google? Yeah. Microsoft, Google paid last year $2 billion in licenses to Microsoft for Android. Why do you think that is? Well, do you think, as an Android person, do you think you're Google's customer? No, you're Google's product, right? So that's why I use iOS products. That's why I want to pay for products. That's why I between a free product and a paid product, I always go for the paid products. Because I want to pay for things with my money, not with my privacy. Simple as that. It's my choice. Right. So let's see development tools. Now, lots of, you can have religious wars over this. So you know how it is, especially developers, or the commerce, or semiconductors, on the next line, or not. So developer tools. In terms of development tools, we have this big IDE called Xcode. This one comes, you get it for free. Obviously, it works only on a Mac because it's an Apple product. You can get it for free from the App Store, and it installs a range of tools on your computer. And this is the only thing you need to develop apps, to start developing apps. You'll use other tools from third parties, but this is the main thing. So this is like the Eclipse of Xcode. Although I don't try, the Eclipse of the Macs. I don't use that analogy because I think Xcode is way better than Eclipse, but yeah, at least runs faster. So what you get with Xcode, you get this huge window where you get different areas to do different things. So you have the navigators on the left, and you can select different way of navigating. So you can navigate based on the files, you can navigate based on the breakpoints, based on the classes, and all sorts of other ways. And then you have this main area where it changes based on what you select here. So what you see in the main area is the project details, right? So you select the project, you see the project details. If you select a .m file, which we'll see in a second what it means, it's a text file, so you'll see a text editor. And then you have this area on the right that gives you properties of what you have displayed in the main area. So for a project, you don't see much. For a file, you will see different characteristics, like including the project and so on. What's more interesting is we have this notion of storyboards. So you'll have something like a visual editor that can drag and drop things. Now this is where this area actually becomes more interesting, because every time you select a button or an element of the interface, you can see all these properties on the right, so you can modify them and add things to it. Right? So with that, you get this simulator, which you can use to make your development faster. So you don't have every time you want to test your project to actually run it on the phone, on the physical thing. You run it really fast on the simulator. And if you used a simulator before, you know they're quite clunky and slow. Well, this one is pretty fast. So let me show you how you can get actually that whatever you saw there running. So it'll literally take a minute. So I think you can see what I see here. So if you start Xcode, and I'm going to create a new project, and I'm going to create a single view application, and I'm just going to give it a test.2, and I'll put it on my desktop. One thing you'll notice here is you'll have this Git repository thing. So this mouse skips me. So what Xcode does for you, it creates a Git repository, so it kind of hopes that you use the right tools. I mean, Git is optional, obviously, but you need to use something, and I definitely encourage you to use something distributed, like Mercurial, Git, all the others. Yeah, use a good tool to manage your code. And literally, that's how it creates the project. Now, Xcode comes with a lot of built-in templates. So in this case, I've selected a single view window application. What that does, it just creates one screen. So if I run it now, I'll select a simulator from here. So I'll select the 3-inch simulator. So that's the iPhone 5, 5S. So if I run it, that's literally the simulator. You can't see the Chrome around it, unfortunately, because the resolution is small, so it doesn't fit. You will be able to see it if it's full, but it's kind of, the screen is too small, so it can't fit in. So let's see how we can add those controls. So it's literally as simple as selecting the storyboard, and in this screen, drag and drop elements from here, from this toolbox. So I can create a label, put it there, hit a button, and put a segment control. Now, you'll see a lot of blue things happening there as I go, towards the edges. So what those are visual indicators that help you design your interface. Obviously, for example, in this case, the reason we have one to the left and one to the bottom is because you don't want to put the controls too close to the corners or too close to the edges, because that's hard for user to touch, right? So it's those indicators about 20 pixels from the edge. It tells you you're going too close. It doesn't prevent you from putting things too close, but it's a visual indicator, a hint that you shouldn't do that. And now if I want to test it, I'll just run it again. And it goes again to simulator, and I have all that running. Right? So it's literally as simple as that to get things running. And you saw how fast it is to open things in the simulator and kind of recompile and rebuild and put it again in the simulator. One thing you probably didn't notice is the fact that it took way less in the second instance than the first. And that's because Xcode does incremental compiling, so it will only recompile the things that you modify. And that's because they use this new compiler called LLVM and something called Clang, which allows Objective-C to run on this LLVM compiler. And LLVM is not specific to Objective-C, it's actually written in C++ and can be used by anything. It's like a bigger brother of GCC, if you like. The clever bigger brother. Or the clever smaller brother, because it's younger. So that's kind of how you get things rolling. Right? So together with Xcode, actually when you install Xcode, you also install a collection of tools called instruments. Now this allows you to debug and test your apps. So we're going to talk about these a bit later, but you can test different things like memory leaks, if you allocate too much memory, how much battery you use, how your app behaves in different scenarios and so on. And in this case, for example, I check how much memory I allocate when I run. Now recently, or in the last year or so, there was a big thing happening in the iOS community. And if you guys know, is any Ruby developers in the house? Anyone using Ruby? No, okay, also. In Ruby we have this concept of gems. And those are libraries that he can create and share with other people. And there's a big repository of gems. Now, CocoaPods are exactly the same thing. So they're open source, or they can be closed source, and you have access to a static library. But you can bring it to your project and kind of not reinvent the wheel. So one that is used a lot by a lot of people is called AF networking. And what that does, it makes it really, really easy to consume resources from the web. So reading XMLs or JSONs or whatever, doing web calls, it's really, really easy to do. By the way, this slides I'm going to put on my website, so you'll have access to all of these. And I think they're available through the main app for the conference. Now, there are lots of other tools, but one tool that I like in particular for this one is one to debug the interface. So how do you know what's displayed on the screen and in what order? We'll do a demo of this later. But this allows you to actually decompose your screen as it runs on the phone and have a 3D visual image of what's in there. You'll see later on what it does. But one of the main things, and this is, I think, it's a big winner for the iOS ecosystem, is the fact that documentation is absolutely fantastic. Everything is documented, everything has a long description of what it does. It has examples. So this is actually inline documentation. If you select, I'll show you quick because I have an Xcode project still open. So if I go into this project, let's pick this one, and I don't know what that view load method does, right? All I have to do is just press the Alt key and I click on it, and it has inline documentation. So it tells you what it does and so on. Not only that, but I can actually go inside the main documentation area, and it gives you more details. And also it has the latest sample code. All sample code, if you click on one of those, what it does, it takes that code, creates a copy on somewhere where we specify, and then you get the source code for the entire project. So you can go and see how Apple does things. Those projects are actually built by Apple. But some of those have code that's a bit stale, because some were built back in iOS 3, 4, 5 days. But it's a good way to find how things are built by people who actually build the entire ecosystem. Also, one thing you can do, so if we go back and call that inline documentation, you can actually go in the .h file. The .h works a bit like the .h in C and C++, and you can see where it was declared, right? So you can see that what it does and another description and so on. So it's really easy to go in and especially if there is a obscure framework that you don't necessarily know what it does, you can go both ways and find the best answer. Okay, so this documentation is actually accessible from within your Xcode, and there's a way to get it from the menu, so you don't have to go for a certain object here. And it's fully searchable as well, so if you search for something, you'll get all the instances where it is mentioned. So this is an example. I searched for something called a UI view controller, and it tells me all about it. It tells me what all the inheritance paths, so I can see where it goes, what protocols it actually follows. We'll talk about those again in a bit. Yeah. And a free third-party app that is actually extremely useful for me, and I've been using this for a long time, and it's not specific to iOS. It's something called Dash. And I think it only exists on the Mac as far as I know. But it's a really, really clever app that allows you to put the documentation for absolutely everything in one single window. So here you can have your PHP, your jQuery, or HTML, whatnot. But what's most interesting is it allows me to put my own libraries in there with documentation if I write documentation for myself. So as a business, if you have a library of code that you use internally, you can create your own documentation and put it in here. And you can create something called a doc set. And if you insert it into Dash, you can actually have it open all the time, and you can search for it and find things. And it's really good if you work in big teams and you share things across. Any questions so far? Cool, okay. So, how do we build great apps? Because that's why we do all this stuff, right? So first, two things to have in mind, especially if you didn't do mobile before. There are two different things, well, two main categories of things that are completely different. So first of all, you have a list of constraints. So you have a small size, you have limited hardware, although this is kind of not an issue anymore with phones released this year or in the last 2 years. They're really powerful. You have one screen at a time, one application at a time, so multitasking is not true multitasking in iOS, and there's a reason for that. You have touch input, so don't design your interfaces to use small buttons, because you don't use a mouse anymore, it's a finger, so you need to make the buttons or the touchable areas bigger. And you have different ways of interacting with that app. So you have the gestures, you have the shake, you have orientation. So orientation can be used in a really, really clever way to make the user experience better. In one of my apps for an estate agent, for example, when you search for properties, if you use it in portrait, it shows you a list of properties. But the moment you turn landscape, it shows you a map. Right? Because it just makes more sense. You don't want to display the same content. And also, if you display a list in portrait, it's kind of boring because there will be long items and you'll have a lot of white space. So by displaying a map, you're actually displaying the same content, but in a different way. And I tend not to actually tell the user whether that happens. So this is one of the Apple mantras, surprise and delight. So imagine if the user by mistake just turns the phone and they see that map. They will be pleasantly surprised because they don't expect that to happen. Audio switch over volume buttons. Some apps use this for creative ways, like before Apple actually used it in iPhoto to take photos, or in Photos it's called. An app called Camera Plus used it, found a way to hack the plus button on the volume. So when you press the plus button, it actually takes photos, which makes sense. It's like a camera, when you press the button at the top. And the home and power buttons, they might not be that useful, but they are there for a reason. Another thing that's different and people don't realize is there's no exit button on mobile apps, right? Because if the user wants to exit the app, they'll just press the home button. At least on iOS. On Android, they have a back button and they go back to the previous screen. Can be different apps, can be browser or whatever. So when I take an app from an idea, guys were yesterday at a prototyping session. I went through this quite in detail and explained how you build prototypes. But when I get a list of features from a client and they request an app, I usually go through this process. That makes it easier to understand what they want and makes it better and easier for me to understand what I need to build. So when they come with a list of features, they usually don't know what they want. So I need to go through this process of filtering and understanding if there are not too many features, so you might need 2 apps. You don't need to put everything in one app. And you can see this with a Facebook app, for example. I'm not sure if you noticed, but Facebook have started splitting their big app into different things. They have Facebook messages, you have paper, which is for reading news. And the reason for that is, it's simple. You don't want to have this big monolithic app which does everything. Because if the user, think of it, if a user wants to read their messages, they'll have to open the Facebook app and go to the messages. There's 2 tabs. What they can do, if you have different apps for different purposes, they'll just open their phone, click on the messages, they'll go straight to the message. Is the fastest way to get the content, is the easiest way to consume it. And then once you decide what features you have and you decide what the app does, I tend to build something called an application definition statement. And this comes from Apple, actually. That's their way of doing things. That's a short for ADS. An application definition statement declares what that app is, how it does it, and audience. Right? So the keywords are there: concise, concrete, main purpose, and audience. And also, I tend to keep this in mind as well. Try and solve real problems. Don't build an app just because you want to build an app. If you build an app for that reason, you probably, I tend to take pride in the apps I build. I don't build them just to build them. So let's see, how do you deliver mobile apps? So when I talk mobile apps, it can be any app in any form that is consumed by a mobile device. Right? So there are 3 ways to do things. Although I tend to say there are only 2 ways to do things. But you can have a web app, right? Should I close that window? So, you can have three different ways of delivering content. One is a web app. So by web app, I mean something like an HTML5 app that you can have on the phone, like offline content. You can use offline data. You can use offline databases and so on. It's very limited by what you can do, but it runs. It's HTML5, CSS, JavaScript works. Another way is native app, which is what we're going to discuss in this talk. And there's a third way called hybrid solutions. And in fact, there's actually a talk right after me in this room about a solution from Microsoft called TFS. Did you guys use it before? Oh, really? Okay. And how do you use it? Do you have just one source?
It's like you can GitHub or something like that. Source control basically. Main purpose is source control, but you're gonna have complete ALM products around it.
So does it mean you have the same source code across all platforms? So does it mean that we have the same interface on all platforms?
You can store anything in it.
Yeah.
If you want, you can store your Word document in it. It's just like more like a version control.
It's an application lifecycle management product rather than just source control.
Oh, I see. Okay.
So it does have product documentation, it does have your work items, their work list, and all sort of things basically.
So when they say that you use that tool to develop cross-platform apps, it's literally to manage code cross-platform, right? Okay. So they're not actually building inside that tool.
It's a MS build manager basically as well, so you can build and then publish.
But it's still in Visual Studio, right?
Yeah.
Okay. So that tool doesn't build on its own.
It's a server machine basically. It's a server, not just.
Right. Okay. Okay.
So,
I'm just curious how people are doing things, because one beef I have with this hybrid solution is it gives the developer the wrong impression. And I was actually looking yesterday at one of the sponsors. I won't say names, but they have a white paper, and the white paper was about the 5 mistakes that you do on mobile. And mistake number 4 was to have different projects for different platforms.
or you're talking about Xamarin Studio basically.
It's not Xamarin. But what they're saying is, it's bad to have different projects for different platforms. Which I think is I thought it's an April Fool's joke, I'll be honest. Right? The reason you don't want that is, and the reason I think Xamarin is okay, but I think they're marketing towards things like that. But they do things the right way because they actually compile to proper code. But if you take things like PhoneGap, for example, right? I don't have it here. But PhoneGap works by using HTML, CSS, and JavaScript. And it creates all this code that runs on top of WebKit. So you get this crappy experience because you work on top of something that works on top of iOS. So it's actually slower than what you will have in the browser. Because there are all of these JavaScript libraries that literally slows down the WebKit. Is there anyone from PhoneGap here, from Adobe? Cool. Okay. That's my problem with that. Things like Xamarin, things like RubyMotion, absolutely fine. RubyMotion, in fact, translates Ruby into Objective-C runtime. So it actually works as fast as Objective-C code. There's no difference there. But the main reason I don't like people using tools like that is because they're under the impression that you develop once and you just use the same app across every single thing. Now that's bad, because an iOS user expects an iOS app. He expects certain things of that interface. An Android user expects an Android app. You will never have a navigation bar on Android, for example. You don't need a back button because you have a physical back button. Right? In the same way, you wouldn't have on Android a tab bar because that doesn't exist. You have a drop down which serves the same purpose. But you will have a tab bar in iOS. So if you put a tab bar on Android, that interface will look like an Android interface. And you create a subpar experience. So I always tend to say, you can use PhoneGap if that makes sense for your business, and if you can't afford anything, use it. But you'll never build a Ferrari with PhoneGap. It'll be like a Ford if you're lucky. Right? Anyway. So, one way to get into iOS development really fast is by using this storyboarding thing, which was released about 2 years ago. And it's just a way to visually design screens and the connection between the screens. I tend to use storyboard for prototyping as well because it allows me to kind of connect between the screens. By default, you actually get it now in Xcode 5. In Xcode 4, you used to, be optional and to put it on. So we saw it before when I was adding those elements to a storyboard. This is where everything starts. So you have where things are starting. And it can go really complicated. I mean, I have an app for a client that it's using probably about 50 different screens, and you can see the connection. And it's really good because you can zoom in and zoom out in the storyboard, so you can get this full idea of what the app does and how it's used. And it's an extremely good tool for beginners. Right? Behind the scenes is just an XML file, nothing else. But Xcode knows how to display it for you inside Xcode, so it's easy for you to use it. At runtime, it's actually interpreted and put in the right place. So let me show you how easy it is actually to build it. So, this one, we'll create a new project. I'll use a single view app again, so we can put it on desktop again. Let's see if I can actually run it on my phone and see if it fits on the screen. No, it doesn't. Okay. So we have a storyboard. We have this entry point here, right? So let's add 2 more screens and add some relationship between those screens. So I'll add just a simple one at the moment. I'll put it there. I can make it small. Unfortunately, the resolution on the screen doesn't help, but yeah. Now what I'll do is I'll put a button on the first one. For this one, you need 100%. And what I want to do is when I tap on that button to display the second screen. So what I have to do is right-click on the button, kind of drag it to the second one, and select model. I'll show you why in a second. And this is where you have this this properties here, which will be, if you click the button, it shows you the property of the button. If you click the segue, it shows you the property of the segue. And one of the properties here is the sort of transition you want. So let's do a partial curl. Right? So look what happens if I combine that and run it. I have that button, and I click, do this. I didn't write a single line of code. So this is, it's something really, really simple, and you can do things like that. So let's now add different, another way of doing things by having kind of what we have in the mail client, where you select something, and there's another view that kind of comes on top, and the other one moves to the left. So that's called it's a navigation controller. So it looks like it works actually internally like a stack. So you have this controller that's managing the stack, and then you just put things on top, and you can always it's the last in first out sort of thing, like a typical stack. So you have the back button that literally takes one and kind of pushes away. So if I leave this one like that, all I need to do is to create that stack. So for that we use something called a navigation controller. So the navigation controller by default it adds its own start, so it needs at least one to display. So if I drag one there, you'll see that it actually has 2. So I'll delete the root one for now. I'll move the starting point to that navigation controller, and I'll say navigation controller should use this one as the root view. Right? So one thing you'll notice also is this initial thing that we have, it gives us navigation at the top. So Xcode is clever enough to understand that screen will become part of the stack. So the screen will be covered on the top part by that navigation bar. So when you put your content, you need to be aware of that. So let's arrange things a bit. Move this one here. And remember we use model for this one, so rather than model, let's do a push, which is push to the stack. So you'll see the second one does that navigation because it sees that it's going to be pushed over stack. But we can do all sorts of simple things like adding a tile for this one. Let's call it first, and then go to this one. Come on. This doesn't want to work. Anyway, you can do it in code. So now you have this navigation, and when we click second, it gives you all this by default. So it has a back button and everything. You don't need to build the back button. Also, one thing you might notice is this back button is the same time as the previous screen. So this back button is actually owned by the previous screen. And by modifying some property on this one, you actually modify how the back button looks in any other view controller when it kind of references back the first one. Right? So I have a demo prepared for you with something. So in this case, what I have in the storyboard is I have a main screen that has 3 buttons, and then when I click on the first one, it shows me one image. When I click on the second one, it shows me this image, and this one has another button that shows a third screen. So it literally takes 2 seconds to create, and this is how it works. Just it's as simple as that. You can use free and just think like that. And close, go back, and all that is done through here. For the last one, you need a bit of code to actually trigger and hit that close button to do the animation in reverse. That's the only thing you have, nothing else. So imagine if you want to prototype an app, or if you want to build just a quick and dirty version of it, you can have everything as images and then just move between images, and you can put it on the phone and see how it goes. Literally as simple as that. So let's continue, because I have about 200 slides, and that's number 41. So, right. The 4, there are a couple of things that you need to know in iOS before you design anything for iOS, and the most important ones are the typical interfaces that you're going to see on the screen. So we have something called table view controller, and both of these are versions of table view controllers. What it is just a list of things where you can have rows. This one is the same one, is the same thing, so you have 2 rows, and you can create any custom view in there. So it doesn't look like a list there, but it's actually in fact a list, because you can add things to it, and you can have as many cities as you want. And all that, the clock and everything is drawn into that runtime. Navigation controller is what we just saw now. So it's a way when you tap on one to go to the next screen. It's a tree structure, if you like. The tab bar controller, it's a way to have separate, and this is one of the things that don't exist on Android, separate entities, separate areas inside your app that kind of work in parallel. So if you think of a clock app you have on the iPhone, you have all these different small utilities that don't kind of make sense together, but at the same time they're too small to put in separate apps. So if you think of alarm, stopwatch, and timer, they kind of work together with the clock. And that's why they put them in there. But to have just one app for a stopwatch is kind of a waste of space. The toolbar, literally the actions you can perform on the screen that you see at that stage. And you have something called collection view, which is a newer thing. So all of these cells, they work a bit like blocks, and you put them together. That's a collection of things. So they can have different different characteristics and different way of presenting. They don't have to have the same dimension. But the good thing about it is you can make a transition between one screen and the next. So if you look at the calendar on the phone, when you tap one of these, it kind of expands into the month. So if you tap January, it kind of becomes bigger and goes to the next screen. So it's a nice effect of visually telling the user that it's going down these slides and content. So, and the same thing happens when you go up. So the main difference between iOS 6 and iOS 7, that's a big talk at the moment, is the fact that kind of things changed, and they changed in a quite dramatic way. We got rid of all this wood and leather and stitch and metal. And basically the interfaces are not skeuomorphic anymore. They don't look like the real thing. There is no reason to look like the real thing on mobile. It's not the real thing. It's a software. So also another thing that's kind of massively different in iOS 6 compared to 7 is there is an emphasis on the content. The content is the one that should take the user's eye, not the Chrome. So if you look at this one, because these areas are dark, we use colors, they kind of draw your eye to them. On the one on the right, they kind of go away, which is out of the user's main attention. Another difference at the moment is different screen sizes. And we're fortunate, but it's kind of strange that I put it in the slides, because if you look at Android, Windows is good because they had some guidelines from day one. Although that day one was 5 years later, but they still have some guidelines. On Android, there are thousands of different combinations of sizes, resolutions, operating systems, and so on. And it's really, really hard to test on Android to make sure that it works on everything. And that's why if you go to the Android store, on apps it says it works on this device, and sometimes they will say the app doesn't work on your device. Now on iOS, you might have an app that is not designed to work on an old version of iOS. So if you have an iOS 6 device, you might not be able to install some apps, but you're not able to install them because they've been built for iOS 7 and above, not because of the device. So the thing to take away from here is you need to carefully test your interface on both screen sizes, because you don't want to have some elements at the bottom and not program them properly, and they will be hidden when you run them. There are ways and techniques to do it properly. Go ahead.
So should we, when build apps, should we not just build them so that they can run on our phone better anyway? Say when another version of iOS come out, another iPhone come out, we don't really want to customize your app to work with that screen size. We actually want it to be actually more generic.
Oh yeah, no, that's exactly how it's done, yeah. We have something called auto layout. And actually from the day one we had spring and struts. So for example, we have a button at the bottom. You want to program that button so it always maintains the distance from the bottom of the screen. And to have things that can change the height, like the table views, for example, automatically adjust the height to accommodate the stuff that you need to move. Things won't change that dramatically for iPhone. There is a talk in the industry about an iPhone 4.5 or 5-inch coming out, might be. But if you use the techniques that Apple tell you to use, it's fairly easy to make sure that it works. Yeah. So let's talk about Objective-C. Anyone use Objective-C before? Apart from you two guys that do iOS. Okay. So do you guys know what's the gang sign for Objective-C?
What's that?
Gang sign for Objective-C. It's a joke in the community, because you have square brackets, the gang sign is like that. Right. So if you go Flickr, you'll find that an album that developers doing the gang sign for Objective-C. It's more of a joke, but yeah, no one does it obviously because we're not gangster. Anyway, so Objective-C actually. It's built on top of C, so it's not only that, it's a strict superset of C. So what that means is any C library will work in Objective-C without any changes. So even C++ can work. There's a way to put C++ inside. There's even an extension of Objective-C called Objective-C++, which makes some, brings some C++ things into the language. But It's an object-oriented language. It's inspired by Smalltalk, so it has the same inheritance as Ruby and other languages. So you can see a lot of common traits in there. It was started by a business called Stepstone, and Apple kind of licensed it. Next step first, and then Apple. And it's kind of the de facto language. So the language that Apple is using, and it tells people to use to build apps on iPhone and iOS. There are ways to do it, but this is what Apple tells you to do. So, how many of you know what an object is? So, use object-oriented. Okay, so it's fairly easy. It's an entity that has properties and methods, right? So, if you think of, back in the C days, you have a struct, which is a way to put data together. This one adds functionality with methods in it. So it's data plus behavior. So in the same way with C++, you have the .h and the .cpp, or the .h and .cs for the C# guys. Here we have a .h and .m. So the reason it's called M is because it's an implementation, right? So you'll have, when you declare a class, so a class is like a blueprint that you use to create objects. When you create a class, you have two different files that they created for you by Xcode if you create using Xcode. And in there you define an interface. So this is the public signature of your class, and you have an implementation, right? So in the class you can declare instance variables. So you can declare properties and behavior. So one thing a lot of people get confused is the syntax of methods. And there is a reason for that, because methods are not methods in the traditional ways. They're actually messages you send to objects, right? So you'll see this when you have multiple parameters, that when you send a method to an object, you actually send a message to that object. So that's the thing you need to have in mind when you think about methods. So you have a return type, like you have in C. You have a name, you have an argument type, and you have an argument name. And that minus there, or dash at the beginning, is actually the type. So that's a method that, it's a typical method you have in an object, right? You can have class methods, which sometimes are called static methods, or things like that. And we'll see those in a second. They will have a class. Right?
What about multiple parameters?
I'll show you in a second. So there's multiple parameters, right? So one thing that absolutely kills people is the fact that parameters are inside the method name. Right? So the method name is actually that one. That's the name of the message you send to the object. Right? So it is application colon, did finish logic with options colon. That's the method signature. Right? The reason you want it like that is, think of your C code. Think of if you have more than 3 parameters for a function. Can you remember the order in which they're in? It's really hard, right? Especially if you have hundreds of functions. You can't remember in which order you have to send parameters in. Now, with this one, it solves the problem. And Xcode has autocomplete, so you don't need to type more than 2 characters to actually have that method appear on the screen. Xcode also knows the context of a class, so it knows which ones to display based on that class, and it gives you a drop down to select from.
Sorry, do you mean that those parameter names, method, I can pass in any order?
No, they're not passing in order, but because they are inside the method name, it's really easy to tell you which order you need to pass them in.
Alright.
Yeah?
So first you will have application and then...
Yeah, so if you read this method, it says application, so you expect an application to be passed. Did finish logic with options, so you expect options to be passed. Alright? This is where it's really different from everything else. You don't get this in language, but I know probably some pretty obscure ones. Right? So these are 2 examples when you can have multiple ones. So it's fairly easy to, and Xcode has this really nice way of actually displaying it by having the colon kind of one underneath the other, so you can see which ones you have. So this method is used to animate something with a certain duration, after a certain delay, with some options, and you specify here what animations you have, and then you specify what code you have to run when you complete those animations. Maybe want to hide, label, whatever. They have there's a block there, so ignore that for now, we'll discuss blocks in a second. So that is actually the method name, right? So when you call it like this. So it's a class method because you have a plus, so it applies to the class called UIView. And then you have animate with duration 1 after 3 0.3 of a second with options. You specify the animations in that in those square brackets, and then you specify the completion. And literally that's how you run the method. So imagine if you have this with parameters at the end. It will be fairly hard to understand each word that you have. That's the reason you have it like this. It's quite verbose, I completely agree with you, but it's really, really readable.
Can you pass a model set plus parameters?
Can you pass what?
Model, DTO.
I'm not sure what
Class, set plus parameters to a method, like
yeah.
1, 2, 3, 4, 5 parameters.
Yeah.
An object with 5 parameters.
You want to pass another object into that method?
Oh yeah, absolutely, yeah. In fact, this is no, you don't have any. The previous one, sorry. Yeah, this is an object here. This is an object there. Yeah, it's a pointer. So you can pass anything. Alright? So let's step a bit back and understand properties.
One quick question. One more.
Sure.
You just mentioned pointers over there. Do I need to manage my own memory there?
We'll get that in a second. You don't. The short answer, you don't. You did back in the day. And the reason you had to do it because you didn't have a garbage collector on the phone. And you don't want a garbage collector on the phone because it drains the battery. So you had to manually manage memory. Now, about 3 years ago, Apple introduced something called ARC, which stands for Automatic Reference Counting. And what that does, literally makes Xcode work for you. So without you having to remember where you need to release your memory and do all the tricks that you need to do, Xcode does that for you at the pre-compile time. So it gets the best of both worlds. You still don't have a garbage collection, but you don't waste your mind cycles on counting memory and making sure that everything is done properly. Yeah? Does that answer your question?
Yeah.
So with properties, remember we said you have instance variables. Sometimes they're called ibars. So if you go out to ibars, that's what you need. They're completely private to the class, so you can never expose those. It's proper encapsulation. So you can write things like a set and a getter to get them out, right? So the traditional language you have set and getters. Now, in Xcode, in Objective-C 2, which was released 7, 8 years ago, they introduced this notion of properties. So for an instance variable, you declare a property with the same type. So you'll see a lot of @ signs. That's kind of a de facto in the language. That's all the keywords have @ sign for them. So you declare a property. You don't have to use the same name. In fact, that name is wrong. You should say number of wheels because you said that they have the same thing there. And you need to synthesize. And that, again, the pre-compiler actually generates the setter and the getter for you at build time. Now, the language evolves all the time, and what they did is they said, well, we don't need an instance variable. We can create that behind the scene. Xcode can create that behind the scene for you. So all you end up with is this property in the interface and synthesizing the implementation. Well, they said, well, they kind of work together, so why not assume that let's do Xcode. Let's get Xcode to do the work for you. So now all you have to do is just create that property. So the reason I put it here is because I wanted to understand what's behind the scenes. It actually creates an instance variable with a random name. It's not actually random, but it's basically a way of getting the name, but you shouldn't use it directly. And you just declare this property. So why do you want to use it? Well, you want to do things like this. You can say my car.wheels equals 5. So that assigns 5 into the wheels property that will assign it into the instance variable. And then in the same way, you get them out with the notation. So that looks similar to the structures in C, right? That's how you access things from the structure in C. So we kind of hinted on that earlier. So a method is actually a message you send to the object. So Objective-C has inheritance in C. So actually behind the scenes, everything is C, right? So actually when you send something, when you do my car drive, you send a message to the my car object with that particular name. So when selector creates a message with that name. So what happens when you have an argument? How do you send it? Well, you send it in the same way, but you pass the arguments in there. A C class can take any sort of parameters, so you can have multiple parameters. Also, you have introspection, and we'll get to that in a second, where you can determine if a particular object accepts a particular message before you send it to it. Now, one thing you have in Objective-C is this strange thing. What happens, do you think, here? This vehicle, my car, is not, right? What happens if you send a message to it? What will happen in, let's say, a traditional object?
No context.
Exception.
No context exception.
Yeah, well, here it doesn't happen. It just gets ignored. And it gets ignored because he sent a message to someone that doesn't exist. It's like calling someone, right? No one will hear it.
Well,
Right.
you got a long point.
What's that?
If you call a non-existent number, at least you got a long point telling you.
Yeah, but it shouldn't program like that. It shouldn't program with exceptions. One thing we also have in Objective-C is this, when you create an object, you create it using the new keyword. It turns out that's actually a two-step process. One is to allocate the memory, and one is to initialize the memory, right? So it's always a two-step process. And it turns out that you can write your own initializers. So you can create, in one go, an object with a certain state. So in this case, I want to create a car that has 4 wheels, right? So I'm overloading kind of the initializer, if you like. And in there, I'm calling, don't worry about that, it's quite complicated, but you always call super init, which is the init of a superclass. And in there, you just set the, whatever parameter you pass, you set it into the instance variable using the properties. Yeah? Not only that, but you can create as many initializers as you want. So it can be really flexible, and you can have an object that is in a particular state because you need it for a particular purpose, otherwise it's the same class. So the way you do it is you'll start with the one that is most specific, so it has the most arguments, the bigger detail, and you'll save that. You save the values. And then when you have things that kind of don't have all the parameters, you need to rely on that one. That's called the designated initializer. And you should always have just one designated initializer, and all the others should call this initializer all the time. So in here, for example, if I initialize with number of wheels and number of seats, I'll just put things in there. But if I initialize it with just wheels, a good practice is to give number of seats a value, a default value. And you do that by having some constants that you kind of use in there. So that's how we use it when you have multiple initializers. You can do the same thing for seats. And then you can actually write your own init. And when you use just that init, it creates an object, with a particular state. If you don't overload init or don't create your own initializer, what it does it initializes every single instance variable with a default for that particular time. So the integer will be 0. The string will be empty. If it's Boolean, it will be, I think, yes, because that's the default, and so on. We have inheritance. It's single inheritance, before you ask. And everything inherits from this magic NS object. We'll see in a second why. So if you want to create a subclass of this vehicle, let's call it truck, you just inherit from that one. And it can have its own instance variables, it can have its own properties, but it also inherits all of this from superclass, right? And you can also overwrite the method in the subclass.
Does it support multiple interfaces?
No, it's single inheritance.
With interfaces as well.
What's an interface?
Or a interface, like say for example, there's an interface called as iVehicle,
Right.
right?
That's a class.
You declare that as interface, right?
Yeah, but that's a class. But the interface is a keyword that you use in Objective-C, but it's a class. It's not the interface that you know in your
Right.
interfaces. Okay? Yeah, so
Two different.
you remember in Matrix when Neo went to see that kid, right, with a spoon, and he said, well, there's no spoon. Yeah, that's exactly what you should do. Just clear your mind. Clear your mind. It's a completely different thing. Yeah, so this is a class. It's not an interface. What you know is interface. The interface is the keyword because you declare the interface of the class and the implementation of the class, right? Actually, that's an interface. Sorry? Okay. So ultimately, everything inherits from this LS object, which is the kind of de facto for everything. So kind of have this huge structure that eventually inherits from there. So when you have a button in the interface, that button actually inherits from a UI control because it knows how to kind of do sorts of control things. UI view because it knows how to draw itself. UI responder responds to touch, and then ultimately from LS object. So let me blow your mind a bit. Let's talk a bit about inheritance and how things are. So you have an instance, right? That instance is a particular class. So what happens in Objective-C has a link to the class. And the class is a struct underneath of sorts. So when you have a class method, something that applies to the class, where is that defined in the structure? Well, it can't be defined in the class, but it's defined in a meta class, right? So the methods that you have here are actually the class methods. The class turns out to be actually an object in its own. So if you know in Ruby, that works exactly the same thing. So then each class has a superclass, right? So it has a link to the superclass. In the same way, the meta class for that superclass has a link to the meta class. So it has this two-way structure that goes down. So ultimately it goes to NS object, right? And NS object has a meta class on its own. And what do you think is the superclass of NS object? It's no, well, it's probably hard guess, but what's tricky here is that actually the superclass of the meta class is the NS object itself. And this works exactly the same thing like Ruby. It's a bit of a cycle there, it's kind of hard to get, but it benefits from everything that you have in NS object to do the meta class for NS object. So the thing to take from here is the fact that an instance has a link to its class, and that class has a link to its meta class. And that's how you can do a lot of introspection in Objective-C. So let me go through this.
So can you access the meta class as well?
Yes, you can get the class of a class, and that's meta class. So do you guys know what polymorphism is? I'm guessing you do, because you use languages. So let's say the vehicle doesn't have a drive method, but two subclasses called truck and car have a drive. Now you can define a variable in such a way that you can call drive on that object without knowing what that object is, right? So you don't really care what it is as long as it responds to that thing. So use the duck analogy, right? If it quacks like a duck and walks like a duck, it must be a duck. So in this case, if it knows how to answer, to respond to the drive method, you can call drive method save to it. Now you notice that the type there is call ID. And also you notice that it doesn't have star beside it, so it's not a pointer. So ID is the generic type. What it means, that object can be anything. And this is where the dynamic part of Objective-C comes in. It means that pointer, well, that object can be of any type. ID is a bit like the star in regex, if you like. It means anything. Right? So, in static typing, you declare for each object what sort of class it is. If you want dynamic typing, you just use ID. Obviously, you probably ask, why don't you use ID for everything? Well, you don't really want to do it, because that means the compiler can't check if you made any errors. Right? But there are cases where you don't necessarily want to tell it that it's a particular object, because you don't know what that object is until runtime. So there's a trade-off to be made there. It's not a tricky one. You kind of get it once you use it, when you need to use one or the other. So you want to use static typing to get the most of the compiler and catch a lot of bugs at compile time, rather than actually having crashes at runtime, just by using IDs everywhere. And even if you use IDs, by using introspection, you can actually understand if that particular object can answer to that particular method. One thing that happens, I was telling you, if you send a method to a null object, it kind of gets ignored. Well, if you send it to an object that doesn't respond to it, you get a crash, right? You'll get an exception. So this introspection is actually implemented at the NS object level, so it's available to all the classes because everything inherits from NS object ultimately. So you can determine if it's a kind of class, or if it's a kind of class that inherits from another class. So each member of class will actually go through all the hierarchy of the classes and check if a class you pass there is actually one of those. We saw earlier how to use response selector. So that basically says this object doesn't know how to handle this message. And you can give a superclass in the class like you said earlier. Right? So that's in this object. Okay. Protocols. Let's say you have a class that has some methods. You don't necessarily, well, those methods can be kind of shared across different things. So this works together with something called delegation, which we'll discuss in a second. But what if you take those methods and kind of put them in a different place, and you kind of use it to ensure that all the objects that work in a certain place actually implement those methods. So that's something called a protocol. So what you'll do is you'll, so you implement it like that. What you'll do, you'll take them out of the class, you wrap it in a protocol, and you'll say, this class needs to follow that protocol. So what it means is you don't define them, you don't declare them in your interface, you only need to define them and create their implementation in the implementation. Right? So when you implement truck, you need to actually create those methods, otherwise the compiler will give you an error. Categories are a way to extend classes without subclassing. But sometimes you want to extend a class without creating another class. So you do that in Ruby, this is called a module. In other languages, called it a different way. But it's a way to kind of overload classes without subclass. There are reasons why you want to do this. Maybe sometimes you actually don't own the class. Like in the foundation framework for SDK, we have something called NSString. NSString is something that Apple defines. But if you want to create a method called word count, for example, in a string, you can't just reopen the class and put it in. Also, you don't own the implementation of that class, so you can't go in there and add it. So one way to do it is to kind of add it, kind of append it to a string. And the main advantage for that is you don't need to go through your code and replace an string with a subclass if you want to add a subclass. You still don't want to use an string, but just have access to this additional method. Does it make sense? So what you do it creates two different files the same way because you need to define them and implement them. So here you'll the naming convention is you use the class name plus the category name. So in my case I use something. Another thing is a lot of people kind of look weird at me when I tell them that in Objective-C you don't have namespaces. Right? It inherits from C, so they didn't have namespaces. The reason you deal with things is you prefix classes with names, with a small prefix. So that's the reason you have NS. That stands for next step. That's the Apple. The reason I use H24 is because my business is called Hello24, and I picked H24 as the three characters that I use to prefix all my classes with. And you don't need to prefix everything. I mean, most of the time you don't really care. But in case there are conflicts, it's better to prefix. So you'll do it into different files in the same way. You need to import to include the original interface about class, and the category will be appended there. And then all you have to do, after you implement it, all you have to do is just include that category. These are the naming conventions. So for classes, we use what's called Pascal case, so the camel case with the first letter uppercase. For objects, we use camel case, and we use prefixes. So NS is for the foundation objects, UI is for the UI kit, so everything that deals with the UI. And it's fairly easy to actually see which class belongs to what framework based on the first two characters, or three in some case. Also, Objective-C has this bool, because this was introduced before boolean was available back in the day. And the good thing about this, it actually defines yes and no as values. And it's much easier to read when you say something equals yes or something equals no than true and false. It just sometimes makes more sense when you read it. Right, so how many of you use Java? Did you use lambdas? Java 8? There's a big word, a big hoo-ha in town at the moment. A lot of people are saying that it's a huge thing. And you guys use Java 8? No? Well, have you used JavaScript? Anonymous functions? Blocks are exactly like that. So it's a way to define code that can run arbitrarily when you need it. Right? So remember we have that, so this is a pointer type and a string that stores a string. And the art is actually to tell it that it's an object. The syntax is really weird, but it kind of makes sense. So what you have is you have a type, which is void. This caret is actually what you'll have here, but they use brackets just to keep it together. And that's the implementation. And this is the parameter that you pass in, right? So a function takes a parameter. Now this is how you kind of say say hello. It's a block that takes in a string parameter. And this is where you implement it. So in a string star, you can put the name of the parameter here, but it doesn't make any difference. You need to put it in when you actually write it. Right? So that one is similar to just created it and then give it a value. And that's in just one step. So those two bits are similar. So if you look at it, it looks a bit like a pointer with a parameter, but it has a caret that signifies that it's actually a block. Does it make sense? So that's the name of the block, it's say hello. And that's what you use there when you give it a value. One thing you need to remember to put the semicolon at the end because we define a block of code. And blocks can be actually passed in as parameters for other methods, right? So in this case, this method's welcome user with block. You actually pass a block that's going to be called when you call that method, whatever you want to do. So in this case, in the implementation, I'm saying welcome user with block, and you call the block and you pass out to that block. Remember, the block takes a string as a parameter. You call the block with something that is specific to this class. So if you create a new user, and if you define that block, when you call the user, welcome user with block, what it does, it goes in and says hello, and then uses whatever user's first name. These two are actually the same as this one. So you can actually create the block when you call that method. Right? So you don't need to actually have a block ready before. And this is why it's powerful. That means that block you define at that point, and it's going to be run whenever you decide to run it. We'll see in a second why. So let's do another thing. What if you want to make this custom, whatever you say here, all right? So what happens is you can define a string that defines this format and literally replace it in there, and that will work as well. And the reason it works is because blocks actually capture the ecosystem when they're run. So at this point, when you create this block here, it knows what the message is because the message is within the context of this. It's within the scope of this block. Right? So if later you decide that you want to modify that message at runtime based on something, so you can say you have some code, and you can say if it's morning, you say good morning. When you run it, if it's morning, it will say good morning, right? But that will happen at runtime. That's why it's powerful. You can't modify the message from within the block. What do you have, like that. There is a way to actually say, if you use __ block, you make this particular variable actually modifiable from within the block. So the block can go back and modify it. There's the difference between passing by reference and passing by value. By default, it captures a read-only version of the environment. And my understanding is similar to what happens in Java 8 with numbers. But I didn't look into that. But why do you want to use it? Why it's powerful? Now, this is a bit of code that you use to trigger an alert on the phone. So that will be that small pop-up that says yes or no, cancel, and so on. So the way you do it, you create one and you show it. Now, the thing with that is, in order to behavioral feedback from the user, so how do you do certain things if he clicks yes or no, for example? In this case, it says, are you sure yes or no? So how do I know to do certain things if the user clicks yes or no? Well, we use this notion of delegate. And what that delegate says is, when the user clicks, you implement this method that kind of gets triggered when that happens, right? Now, these two bits of code are completely disconnected. They can exist in completely different classes and completely different aspects. But it doesn't really make sense, right? Because this need to be kind of coupled together. Because they kind of serve the same purpose. So with Alert View, I've created my own version that uses blocks. So in this case, I say create a with title with a message with a cancel button with some other buttons. And on dismiss, you send some code. Index block is actually just a simple block that accepts a number. So I know which button you click, because you can have more than 2 buttons. You can have as many buttons as you like with it, as you can fit. And then on cancel is actually the dismiss button, which is the one on the left. So this is how you would use it. You would call it and create all the characteristics of alert. And then here you actually pass the code that's being executed when you dismiss or cancel. So the code is actually together with the code that creates that view, that's alert view. So it keeps everything nicely together.
Sorry,
Go ahead.
this the OK button will dismiss that dialog box, right? Over here in this code.
No, the OK button will go on dismiss. Yes, sorry, yes.
And cancel will cancel.
Yeah. That's why you have an array here. That's an array. Yeah, so it's really powerful because it keeps functionality together and you don't have this disconnection of code. So let's go a bit through design patterns quick. So we saw the accessor patterns, so the properties, anonymous type, we saw that a 2-stage creation, and I'll skip through the other ones. How many of you know MVC? Use MVC? We have MVC as a core principle in when you create a project with Xcode. My understanding of MVC is you should never let your model access the view, or you should never let the view control the model. It has access to the model, but it should be a read-only access. Now, if you come from a web background, a lot of people kind of forget the control. So they do a lot of things to do with the view of the model and access directly the model from the view. Now, what I've seen in Objective-C is a lot of people kind of forget the model because it's not that obvious. If you use core data, which is the way to access the data, it is obvious. But otherwise, people do things with the controller that they should be in a model, like storing data in an object. They don't create objects that are actually the model. In fact, the controller is so specialized to deal with the view, so it works together with the view, that's called a view controller, because it manages a view. Right? Also, don't let MVC be the way you design your code. So don't create folders called controller view models. That's the worst way you can actually group your code. Okay? You don't group it based on the values you use, you group it based on the functionality you have. So another thing we have is the decorated pattern. And we saw the categories that adds functionality to a class. We have delegation, which we'll show in a second, so it works in conjunction with protocols. So in this case, by default, when you create an application, it creates an app object, but it creates a delegate for that app. So every time the app does something, it sends a particular method is called on the delegate. So I think I skipped a slide for some reason. Never mind. Another thing we have is called observer pattern, and we have notification. So this is the standard notification. You send a notification, someone listens to it, gets something in return. Kind of disconnected, right? So we have a notification center which works as a singleton, and someone can add yourself as an observer, so you can listen to messages. So in this case, if anyone sends a H24 course notification, I should say do something. The do something method is triggered on this particular object, self. Self is like a this or the keywords in our language. And that's how you post notification. And the reason you have object there is because you can pass data around as well. One thing a lot of people forget to do, and this triggers a lot of errors, is they forget to remove themselves as listeners for that particular thing. So the notification center still sends stuff to you. Now this thing is really powerful. A lot of people don't use it because they're afraid of it. But for KVO and KVC, it's a really powerful thing. So let me explain it quick. If you have a class that has a property called maker, let's say, and you implement that, and the way you call it is you use .maker, or you can use the setter. Because remember, behind the scene, you still have a setter. So it turns out that property, you can actually still access it like you would access a dictionary. We have this thing for dictionaries, and you can get value for key, and you can set it as value. Not only that, but if you have another object that actually is owned by this class called owner, you can go in and access for a certain key path. You can access the properties of the owner. So you can drill down and go all the way in. And this is the KVC. You can set it and retrieve it like that. KVO works a bit like the observer, so it's the observing part of KVC. So in this case, you can add an observer, and you can say every time the owner changes for myself, I need to be notified somehow. Because the owner is an object on its own, so it can be modified by someone else if it has a link to it. And you can pass different parameters and get the old and new value. And you can observe as deep as you like as the structure. And in the same way, you need to remove yourself. So that's KVC. Another pattern we have quite frequently is the facade pattern. So it's a simplified interface to do a lot of code. So think of it, when you have an image in Objective-C, well, in iOS SDK, it doesn't care what type of image it is. It knows how to load it with this just one single interface. So in this case, you can tell it to the contents of files, so you can give it the file path. Or you can say, load an image with a name. And this have been name supported. So you don't really care what's implemented behind the scenes. You have this unique interface that you always use for images. That's a facade. So let's get through this, because this is more interesting. So when the app runs on the phone, which state does it run? Well, it has 3 different states where it can be. It can be no running, it can be running, or in the background, right? So what happens if the background, actually the app gets frozen? It doesn't necessarily run, but it kind of still uses memory, right? So this is another reason why, compared to the desktop, we want to minimize your memory footprint. Let's say you have an app and you put it in the background and it uses a certain block of memory. What happens if a user launches a big game that needs a lot of memory? What do you think happens? Well, the operating system needs that memory, right? So it will clear the memory, it will kill your app. Now, which one do you think it will be killed first? No, all of them are in the background. The one that uses the biggest amount of memory, right? So it's trying to minimize the amount of apps it tries to kill. So if your app uses a lot of memory, there's a big chance that it's going to be killed first while in the background. And the reason you don't want your apps to be killed while in the background is because you don't want the user to wait for your app to load. And also, you want the user always to go back to the exact screen it was when he left your app. Like if you're reading emails or playing Freeze, for example. You don't want to start the game from the beginning. You want to start it from where you were, right? So there is actually still a way to make the apps not run in the background if you want for your app. And a lot of banking apps use this. So the moment you close your app, it gets killed, or it just kind of goes away. Right? And you do that by adding the property to the project to do this. Now this change in iOS 3, so in iOS 4. So in iOS 3 you only had running and not running, and this is where we added what they call multitasking or modified multitasking. So every time the app moves from one state to the other, the app delegate gets a method called to it. So it can do certain things based on its calls. So no running, background, running. Right? So let's say the app goes from no running. Before it goes into foreground, it gets that will finish launching options. So here, it's a chance to actually do something, start getting the data from the network, do other things. Also, the interface is always running on the main thread. So if you run network activities, always run it on a different thread. Never block the main thread because that will lead to a bad user experience. You don't want the user to kind of have a jerky interface or have the interface stuck until you load your stuff from the resources. So always run, and then you can have different priorities for threads. What I recommend is just run it on a low priority in the background if you get data. Obviously there will be cases where, and with an app I'm building now for betting, where you need a lot of data, a lot of fresh data. Now in that case, you present something to the user and he gets things from the background. I wouldn't put it on low priority because the app actually relies on that data to run. Right? So there are different ways to do it. Anyway, going back to this. So from not running, it triggers will finish launching options. It goes to inactive state in the foreground. Now, this inactive state is kind of tricky for people to understand. But what do you think happens when you use an app and the phone rings? Right? Yeah, so it's still in the foreground, but it's in inactive. So what you probably want to do is, when the app goes to from active to inactive, when you get a phone call, to actually stop a game or pause stuff happening or things like that. This is when it's still the foremost app, but it's not running as such. So from inactive to active, it gets a did finish launching options. This is wrong. Shouldn't be here. Should be here. And then you have application to become active. So in here, that means your application is running and it's ready to be used. So you can do all sorts of other things in there. Now, what if you make it inactive? So if a phone rings, it'll go from here to here, it'll get a trigger to application is resign active. So the app is not in the background, but it's in inactive state. And it goes back in there and gets application to become active, so we finish with the phone. So in there you want to present an application to become active, you want to present a prompt saying do you want to continue because your game was paused. So what happens if a user clicks the home screen, or taps the home screen, and the app goes into the background? Well, it goes from active to inactive. It gets the same thing, application to resign active. Then it goes to running in the background, and the background has these two states, where it's running and suspended. So it's suspended is where it's frozen, and kind of it's kept frozen. But it goes through a running process, right? So imagine you have a Flickr client, and you load 100 photos. You're in the process of loading 100 photos. What happens if a user puts it in the background where you load the third photo? What do you think should be a good user experience?
Yeah, keep loading basically in background.
It's not, because you'll use the battery. The user doesn't want you to use the battery. It should finish loading the current image and then stop until the user goes back into the app. So there are APIs that allow you to tell the operating system, I want to run for a bit. So you can actually say, well, I'm doing something, let me run for another couple of minutes to do my own thing. So the app is still actually running in the background. And this is where it's not true multitasking, but you have a bit of multitasking there. Also, you can periodically kind of wake up your app. It goes from suspended to running and then go back into suspended. And this is where you monitor location in the background. So you can have apps that monitor the location. They can, every once in a while, they can wake up and do something with the location. So it goes to running, and then it has this application launching in the background, and it goes to suspended and then it stays there. So the same thing if you want to put it back. So if you bring it the foreground, it goes through all these states. It has different calls being called and so on. Now the app can be killed at any time, right? So what you want to do is when you put your app into suspended, at that point you want to save everything, because the operating system can decide to kill your app because it needs more resources. So it can go from there. There's no callback there because it just kills your app. There's no chance for your app to do something. But also your app can go from active to not running if it's killed. So if I use a double tap home button, then it just swipes up, your app just is gone. So when you double tap, you actually go into the inactive state. So you want to do something there. I'll skip through this because I'm realizing I'm running out of time. So one interesting thing is if you want to test your app in with different network conditions, because if you're running a simulator, you always run through the connection of your computer, right? There's a thing called network link conditioner that allows you to kind of strangle your Wi-Fi connection, right? So you can create different scenarios, and the same thing happens on the phone. So even if you have a phone with Wi-Fi, you can actually go in and kind of replicate a very bad network. So you have a lot of package drops, and if you have 100% loss, what do you do inside your app? So it's a really good way to test in different scenarios what's happening. So the previous one, this was on your Mac, so if you're running the simulator. This one is actually part of the developer menu that you get on the phone. There's a good tool from Square. So the Square is made by the same guy that studied the main guy. It's called Pony Debugger. What it does, it allows you to install a Python small server on a machine, and then you use the Chrome debugging tools to so you'll have access to all the stuff that you normally have like a web page. Not only that, but if you use core data, you have access to the database. So it will look like the local storage in HTML5. Not only that, but you recognize this, right? It looks like HTML. It tells you what it is. You can actually go both ways. You can modify a property here and have a interface modified. So it's really, really powerful. This is reveal. Let me do it quick because I think you'll be impressed. It's this one. So what I did is I included a framework that they provide, and that creates a socket between my app and their software. And so in this case, I'm loading Hacker News, right? Like any good developer would do. And this is the list of things they have. Now, what if something happens weird on the screen and don't know where it comes from? Well, if I load reveal, that allows me to connect to YAM, and it gets an image of YAM. But I can do things like this, right? Look in 3D what's happening inside there.
Those are the layers of those UI basically.
Literally every single thing that you have there. So you can see you have a table view that has some sort of cells. So if I go back to this one and literally go into one of them, this will be a long one. I can click refresh here, and it shows you every single thing that you have there. Right? So it's a really, really good tool. And you can see it has this toolbar here, and the way it works is actually it's hidden underneath the next one. So if you want to comment on something here, so this is a comment. If you click on it, it shows that toolbar. And it does that just literally by moving this up or modifying its height. But you can see internally that's the way they implement it. And it's a really good tool. And it goes both ways as well. So if I make it bigger, I can go in here and modify this bit. It's a label, I'll type something. This should, no, didn't work, sorry. Let me go back and modify something else. Sorry. Anyway, you can go in here and modify all your properties to do this, and that will actually reflect in the simulator. So if you want to change the color of this one, you can do it directly. This is really good if you work with a designer and they say certain things are a bit to the left or to the right. You can go in here and modify the properties. And once they're happy with the simulator, you just take that property and put it in your Xcode project. The values that you have. And it's a really good tool. Again, it's a commercial tool. It's quite, I mean, it's not cheap, but it's really good, especially, you know, if you work in a business. I'll put the slides online so you can see all this ad hoc and distribution. It's quite a long way. Unfortunately, this is a 2-day course, but I tried to, actually on Monday I did it as a 1-day course, and I think it worked quite well. But doing it in 90 minutes is kind of hard. So thank you very much for coming. My details are there at the bottom. So feel free to follow me on Twitter, and I'm same handle matt.net if you use that. That's my email address. I'm more than happy to answer questions. The slides will probably be on the website as well, or my personal one. Thank you for coming, and I hope you enjoyed it, and I hope you learned something. Thank you.